Hello everyone, in this tutorial we will cover the topic AES algorithm. AES stands for Advanced Encryption Standard, and with the help of an example and flowcharts you will understand how this algorithm works. So let's see. What is AES? It is a popular and widely adopted symmetric encryption algorithm found at least 6 times faster than triple DES. A replacement for DES was needed as its key size was too small. With increasing computing power, it was considered vulnerable against exhaustive key search attack. The following are the features of AES. It's a symmetric key block cipher, 128-bit data, 128, 192, 256-bit keys, stronger and faster than triple DES, provide full specification and design details, software implementable in C and Java. So step 1 is generate the round keys. The plain text and the key may be provided as in the form of a message. So in that case, convert it first into hexadecimal to get something like this. So taking this example, let's proceed. Split the key into 4 words: W0, W1, W2 and W4. Take 4 bytes and these 4 are W0, these 4 are W1, these 4 are W2 and these 4 are W3. Now take W3 and perform one left shift. That is, 75 will come here, 46 will come here, 20 will come here and 67 will go to the first position. After doing this, you will get this result. Now we will do S-bus conversion. So how do we do it? Like we have 20, so we will move to second row and 0th column. We get B7. That's why we got B7. For 46, we will go to the 4th row and 6th column to get 5A. So that's why it's 5A. 75. 7th row, 5th column. That is 9D. That's why it's here 9D. 67. 6th row and 7th column. That is 85. And that's why it's 85 over here. So after getting this result, we will add a round constant. That is, we will XOR this result with this. Since the last 3 are already 0, so these 3 won't change after XORing it with this. So 5A, 90, 85 remain as it is, and after XORing B7 with 01, you get B6. Let us call this G of W3. So now you will XOR G of W3 with W0, which you already have. After XORing these two results, you will get this, and this will be your W4. Now there is a pattern. Once you got W4, you will XOR it with W1 to get W5. Once you got W5, you will XOR it with W2 to get W6. Once you got W6, you will XOR it with W3 to get W7. After doing this, you are getting 4 results, that is W4, W5, W6 and W7. Now merge all these 4 results and get the first round key, which is this. Now similarly, when you got the first round key, you will again divide it into 4 parts. You will take W3 again and perform 1 bit left shift on W3 followed by S-bus conversion, then adding a round constant, then XORing G of W3 with W0 to get W4, and similarly you will get W5, W6, W7 and get the second round key. So this process will be followed for 10 rounds to get 10 round keys. So after getting all the round keys, this will be your result. Now let's start with the main procedure. We will now select round 0th key. So the plain text is already given to you, and you will take the 0th round key, which is this. You will XOR both of them, and the AES output after round 1 will be this. Once you got this matrix, you will perform S-bus substitution, which you already know how to do it. So I will just show one more time, like 0, 0. So 0th row, 0th column, 63. So we will fill 63 here. 3C. So third row and C column, that is EV. So EV will be filled here. So in a similar way you will fill all these 16 positions. Once you are done, you will do left shift based on the rules below. Now let's see what these rules are. The first rule is the first row is not shifted. Okay, so 63 EB 9F A0 is placed as it is here, no change. But the second row is shifted one byte position to the left. Okay, so 92 has come here, 93 has gone here, 2F has come here, and C0 has come to the first position. So this is one left shift. For the third row, we will perform two left shifts, and for the fourth row, we will perform three left shifts, and at the end, you will get this matrix. After getting this matrix, we will perform mixed columns to get this result. So how do you perform mixed columns? This is a bit elaborate procedure, so let's get started. For mixed columns, you need a standard input matrix, which is this, and let us name this matrix as M for the time being. So you have to multiply these two matrices, the standard one with M, and the final result will be this. So how do we get this? We will just see. As you can notice, the standard input matrix contains 1, 2 and 3. So there will be 3 rules in total, that if you multiply a number with 0, 1, what is the procedure? If you multiply it with 0, 2, then what is the procedure? And if you multiply it with 0, 3, then what is the procedure? So you have 3 rules in total. So multiplication will be carried out as follows, like take the first row and take the first column. So the multiplication will be 0, 2 with 63, 0, 3 with 2F, 0, 1 with AF, and 0, 1 with A2. So all these multiplications you have to perform. So for 0, 2 you will have to perform the case 2 rule, for 0, 3 you have to perform the case 3 rule, and for 0, 1 you have to perform the case 1 rule. So let us take a look at these rules. So for case 1, that is if you are multiplying it with 0, 1, then there is no change. Just convert the hexadecimal into binary and simply store it. In the case 2, we will take that hexadecimal and convert it into binary. Then we will check the MSB, that is the most significant bit. Most significant bit is actually the leftmost bit in the binary form. So if that is 0, then do one left shift, and that will be your result. But if it is 1, then do one left shift, and after that XOR it with this to get the result. Now what if you are multiplying it with 0, 3? Then 0, 3, in 0, 3 first you will perform the rule for case 1 and then for case 2, and the result you get in both of them, you will then XOR them and get the final result for case 3. So when you are doing case 1, you will just convert it into binary and just store it. But if you are doing case 2, you will again check the MSB. If the MSB is 0, do one left shift and store, and if it is 1, then do one left shift followed by XORing it with this and then storing this. So you are getting 2 results, either store 1 or store 2, and then you will XOR both of them to get the result for case 3. Now let us see how we use it. Like for the first calculation, 0, 2 into 63. So we will apply case number 2. So for case 0, 2, you will first convert 63 into binary, which is this. Then check the MSB. So MSB is 0. So when it is 0, we do one left shift and just store the result. So we are doing one left shift, we get this and we store it. Next calculation is 0, 3 into 2F. So for 0, 3 we will perform the case 3. So for case 3 we will perform first the case 0, 1. So when we are performing case 0, 1, you just convert it into binary, which is this, and store as it is, no change. But when you are doing case 2, after converting, you will check the MSB. So here MSB is again 0. So when you have MSB as 0, you do 1 left shift and store it. So once you got the result for store 1 and store 2, XOR these both results and get the result for case number 3. So till now you have got 2 results, one for 02 into 63 and 03 into 2f. Now the third calculation is 01 into AF. This is easy, just convert AF to binary and store it. This will be your third result. And then 01 into A2, this is also the first case, so no change. Convert A2 into binary and store it. So now you got 4 results. Now combining all the results of the first column, you will get this. These are the 4 results that you just calculated. So we will XOR all these results and we will get this final result. So convert it into hexadecimal, and the hexadecimal will be BA. So fill the corresponding position in the resultant matrix. So that will be this position, because first row and first column, so it will be BA. Next is similarly follow the same for all the columns one by one. Like you took this row, so do the same for the remaining columns. And once row 1 is done with, you can proceed to the next row. And do the same procedure again for all the remaining columns. Now let us take another example. When you have taken the second row and the first column. So these will be the multiplication to be carried out. 01 into 63, 02 into 2f, 03 into AF and 01 into A2. So 01 case, which is marked in yellow, these are easy. You just have to convert 63 into binary and store it. So this will be your first result. You have to convert A2 into binary and this will be your second result. Then you have to do 02 into 2f. So for the second case, convert 2f to binary and check the MSB. As you can see, MSB is 0. So when it is 0, you do 1 left shift. After doing that, you will get this result. And A2 we have already calculated. Now 03 into AF. There is a twist here. Like till now, in all the calculations, we have the MSB as 0. But what happens if the MSB is 1? Let us see that part of the flowchart. So when we are calculating 03 into AF, so we will take this root. So when we are applying the third case, we will first apply the first case, that is this portion. So when we are applying case 1, we are simply converting AF into binary and storing it. Next, we will perform case 2. So AF is converted into binary, MSB is 1 in this case. So when MSB is 1, we do 1 left shift. Okay, we have done 1 left shift, and after left shifting this one time, we are XORing it with this value. So we XOR this value with this value to get a new value, which we call as store 2. Now we will XOR the store 1, that is result from case 1, and store 2, the result from case 2, to get the result of 03 into AF. So this is the result. So you already got 3 results earlier, and this is the 4th result. So XORing these 4 results will give you the final result for that position. So you got this, and this the binary for 45. So since it was second row first column, so second row first column will fit 45. So in a similar way, you will keep filling all the 16 positions. So the matrix after mixed columns will be this. This is your final resultant matrix after mixed columns. So after doing this, we will proceed to the next step, that is, till now we have used the round 0 key. Now after doing mixed columns, we will use the round 1 key. This is the round 1 key, and this is the one we have just calculated after mixed columns. So when we XOR these both results, we get the AES output after round 1. So this is our AES output after round 1. Similarly, when starting with round 2, we will follow the same procedure again. We have this matrix now. We will perform S-bar substitution. We will get a matrix. We will perform left shift based on the rules. We will get another matrix. Then we will perform mixed columns and we will get another matrix. And at the end, we will XOR it with the round 2 key to get the matrix at the end of round 2. And the same procedure will follow for round 3, round 4 up to round 9. In the last round, there is an exception that we do not have the mixed column step. So after we do the substitute byte and shift rows and all those things, we'll directly do XORing with round key number 10. So after we get this result, we will XOR it with the round key 10. There is no mixed columns. This is a point to be noted. And after doing that, we get this result, and if we write in a linear fashion, we will get this ciphertext, which is your final answer. So I hope you understood the tutorial, and if you like this, please don't forget to give a thumbs up, and you're free to share your views and comments, and share your support by subscribing to the channel. Thank you.